In this video, we'll look at box and whisker plots, or box plots for short. Box plots are used to display visually descriptive or summary statistics in the statistical investigation process. In particular, parallel box plots are useful for comparing two sets of data and help when moving to the interpretation and conclusion stage of the statistical investigation process. In this video, we'll have a look at what box plots are. We'll have a reminder of what the 5-figure or number summary is, a reminder of what the outlier test is. We'll look at drawing box plots and drawing parallel box plots. A box plot or box and whisker plot is a graphical or visual representation of some of the descriptive statistics of data. Specifically, they deal with the 5-figure or 5-number summary, which divides the distribution roughly into quarters. Box plots clearly display the minimum and maximum values, the median, the quartiles, and any outliers. Box plots give a clear indication of how data is spread, as their interquartile range is shown by the width of the central box. Before you can draw a box plot, you need to be able to find the 5-figure summary. The 5-figure or number summary of a distribution consists of the minimum, maximum, lower quartile, the median, the upper quartile. Please refer to my measures of spread video if you need further information on how to calculate these. The lower quartile is above 25% of the data values and therefore below 75% of the data values. The median is above 50% and below 50% of the data values. The upper quartile is above 75% of the data values and therefore below 25% of the data values. Once you've found the 5-figure summary, you need to identify any outliers, as these are recorded separately on a box plot. Outliers are observations outside the vicinity of the rest of the data. A data value is lower than the lower boundary, it is considered an outlier. If a data value is above the upper boundary, it's considered an outlier. Please refer to my outlier video if you need further information on how to find these. Let's look at how to draw a box plot. First, we draw and label a number line or scale that is larger than the range or distribution of the dataset. Then we draw a vertical dash above the number line or scale for each of the 5-figure summary data values. Then we draw a central box from the lower quartile or Q1 to the upper quartile, Q3. And then we draw a line through the central box at a point where the median is. Then we extend lines from the box out to the minimum and to the maximum on either side, excluding any outliers. And last of all, we mark any outliers with a cross or an asterisk. Let's look at how to draw a box plot. So we draw and label the number line or scale that's larger than the range or distribution of the dataset. Then we draw a vertical dash above the number line for each of the 5-figure summaries. The first one is the minimum value. The next one is the lower quartile or Q1. The next one is the median or Q2. The next one is the upper quartile or Q3. And the next one is the maximum. Draw a central box from the lower quartile or Q1 to the upper quartile Q3. Ensure you have a line wherever the median falls. Extend lines called the whiskers from the box out to the minimum and maximum values that are not outliers. And then finally, if we had one, you'd mark your cross or asterisk for an outlier. And there it is. Box plots give a clear indication of how data is spread, as the interquartile range is shown by the width of the central box. You don't need to draw this on your box plot though, but I've identified it here for you. Here we have a data set that we've ordered and calculated the 5-figure summary for. Please refer to my measures of spread video if you need further information on how to calculate these. We're going to use this to construct a box and whisker plot. So first of all, we draw our number line or scale that's greater than the minimum and maximum values. Then we draw a vertical dash above the number line for each of the 5-figure summaries. So we start with the minimum. I work from left to right, and then we put Q1 in, Q2, Q3, and the maximum. And we draw a central box from Q1 to Q3, which is the lower quartile to the upper quartile. Then we extend lines from the box out to the minimum and maximum values. These are called the whiskers, and that's where the name box and whisker plot comes from. And lastly, we mark a cross or an asterisk for any outliers, but we don't have any in this example. Here again, I've marked for you the interquartile range, although you don't need to do that normally on your box plot. Here we have another data set with a 5-figure summary. Let's follow the same process and draw another box plot. So we draw and label a scale that's larger than the data set that we have, the larger the minimum and the maximum. I can't fit up to 45 on this with my outlier, so I've marked my scale with ... up to 45. So we draw a vertical dash above each of the 5-figure summary. So we've got the minimum, Q1 or lower quartile, the median, which is Q2, the upper quartile, which is Q3, and the maximum. Then we draw a box between Q1 and Q3. Ensure you have a line indicating where the median is. Extend lines from the box out to the minimum and maximum values. And you mark with an asterisk or a cross wherever your outliers are. So I've marked it here. Parallel box plots are 2 or more box plots drawn on the same scale. They're used to compare 2 sets of data within the same context. A parallel box plot used to make a visual comparison between 2 sets of data. This allows us to compare the distribution using descriptive statistics. Here, all it is 2 box plots, one above each other. Sometimes they're next to each other vertically, so left and right. You might see that sometimes. But we essentially follow the same process to draw them. Here we have parallel box plots comparing the customer satisfaction rating of 2 large department stores. A customer satisfaction rating is often a leading indicator as to the success or failure of a brand's customer relationships. Parallel box plots allow us to make a visual comparison between the 2 stores. If the industry mean is 5.5, what percentage of the time were each store above average? Just over 3/4 of store A scores are above 5.5, therefore they are above average 75% of the time. And you can see that because they've got their right hand whisker and then 2 sections of the box. They all represent 25%, and all 3 of those are higher than the average. Just over half of store B scores were above 5.5, therefore they scored above average greater than 50% of the time. And you can see that because a whisker and then part of the box which is above the median, it represents 25% of the data, plus the whisker, which is 25%. So store B, greater than 50% of the scores were above average. You can also interpret other things from the parallel box plot. Store A overall has a far better customer satisfaction rating. Given the box plot is less spread out, they're also more consistent. Their minimum score looks like it's around 4 in comparison to store B, whose minimum is 1. Both appear to have scored a 10 rating, but store B's 10 is an outlier. More information will be needed to verify the 10 for store B. The right whisker, which represents 25% of store A's results, is almost entirely higher than store B. This suggests that almost 25% of the time, store A receives a better score. Neither store A nor store B box plots are symmetrical, which is indicated by a slightly longer whisker on one side than the other, as well as the median line won't be directly in the middle of the box. There's a number of things we can interpret from parallel box plots like this. So in summary, in this video we've had a look at box plots, what they are. We've had a reminder of what the 5-figure or number summary is, a reminder of what the outlier test, and then we've looked at drawing box plots and drawing and interpreting parallel box plots. Thank you.